This is live, isn't it? How close do you have to be to it?
I can hear you.
It's okay, isn't it?
I think if you speak out, it'll go out. It's on.
Well, good evening, everybody, and thank you for coming to our program meeting tonight. We've got an exciting program by Dr. Mark Nolen, who's also the Vice President of the Wichita Audubon Society. So we're really pleased to have him come along and talk about one of his favourite subjects. So my name's Barbara Govert. I have the honour of being the President of Wichita Audubon this year, and I'd like to thank you all for coming out to our program this evening. So just a few announcements before we start regarding some field trips. Next Saturday, we do have our Saturday morning bird walk here at the Great Plains Nature Centre. That's proving to be very popular. We're getting sometimes over 30 people coming, and thank goodness we have some experienced birders so we can split into smaller groups, but we've been finding some really great birds recently. Last trip, there was a juvenile little blue heron in his calico colours. He was really beautiful. And after that, on Saturday, October 21st, we have our field trip out to the Marion Reservoir. You're leading that, aren't you, Kevin?
I think it's
Tom's leading that one?
Tom might be.
Tom is, sorry Tom. So Tom's leading that one. And also, I wanted to let you know that our extended field trip for 2024 is going to be to the Hutton Ranch up in Nebraska. So the sign up is on our website. Look under field trips and just keep going through all the field trips. It's the very last field trip there, and there will be a link for the sign up page. We are having to limit numbers this year because there's limited accommodation at the Hutton Ranch. So if you're interested, when you leave here, go and sign up, please. But it should be a really great trip up there. Bob, where's Bob? Bob also had an announcement about a field trip.
Do I need the mic or can you hear me okay? The extended field trips Wichita Audubon Society has been doing forever and have gone coast to coast. And usually the extended field trip is announced at the beginning of the Audubon year. But we're working on something that we've never tried before, and we want to check to see if we've got enough interest to make it go. But we've got information back, and what we are looking at is January of 2025. So we're looking at a little over a year from now. We're looking at taking a Wichita Audubon Society group to Puerto Rico. Now, to go to Puerto Rico, we have to work with a tour vendor, which means that they have to book further in advance than what we're used to, which is why we're making this announcement now. We're looking at a maximum of 14 people. We'll have two 15-passenger vans with the back seat removed for luggage. Everybody will have a window seat, which means we can take 7 people per van. It'll be working with one of 2 vendors that we're still working with right now. We expect that the price for the tour only, which is a flight down, 5 full days of birding, and then the flight back, is going to run us about $2,800. I checked today to see how much flights were, and I saw some at $320. They'll be higher than that by then. And so I think we're looking at, somewhere in the neighborhood of 3,000 to 34, or somewhere in there, depending on what happens. And so if you think you might be interested, we're targeting the endemics, depending on who you read. It's either 18 or 19 species that are found only in Puerto Rico, and we'll be looking for those in particular. If you are interested, I'll be right up here after the meeting. I need for you to come up and pick up one of my business cards and send me an email that says you are interested. And then we'll be taking a list of people's names as they come in, and the first 14 get a go. And we hope that we have enough that can go. So we're looking at January of 25 probably in the middle of the month. Carol?
If you don't get 14, will you take 7?
I think we can take 10 at that price,
Okay,
but if we go down to 7, the price will go up.
okay.
But if it gets there, then we'll get in touch with the 7 that have signed up and ask them if you want to pay more and go with one group.
Okay.
So,
You don't need a passport to go to Puerto Rico, do you?
no, Puerto Rico is a part of the U.S.
Right.
No passport needed.
That makes it a lot
Yep.
easier. Thanks, Bob. Okay, so I know on the Facebook pages and that, quite a few people have been noticing that the Mississippi Kites have headed out for their winter vacation down south. And Sandra, I think you've got a story to tell us about that. Do you want to do it from there, or would you like the microphone?
I have a loud voice. Can you hear me?
I can hear you.
Okay. I live in a patio edition of old people of 17 in a semicircle and with an island in the middle. And about 10 days ago, I heard a whistle call. And I thought, that's unusual, but I didn't investigate. And the next day, I went out, and the whistle call was calling and calling and calling. So I got my Merlin app out, and it ID'd it as a Mississippi kite. And I thought, that's unusual. They're on migration. They're not going to be staying. He isn't going to be staying here. Well, it turned out the next day, I saw it in the island, and I got a good look at it. And it was a juvenile Mississippi kite. And it was just like it was crying, help me, help me, help me, because it kept on whistling and whistling. And and I was looking around, and I had half the neighborhood looking, and they were all excited about this bird. So it turned out about the 5th day, I got a call and said, Sandra, come over here. We have your bird, we think we have your bird on top of this car. So I went over there, and there were 8 people around looking at this bird. And it turned out it was some visitor's car, and she wanted to leave. And they didn't know what to do. And I said, well, let me go home and get my cell phone, because I want a picture of this. So as I was coming back, the bird flew into the island. And the next day, we were listening, we didn't really hear it. Just heard a faint call. And about the 7th day, I got another call. Sandra, I think we have your bird here. And it was deceased. It was dead in the grass. So it probably died, I think, of starvation, because it wasn't able to go very far. And I talked with Tommy Ewert, and he said it was probably a bird that hatched and wasn't able to migrate. It was just flying enough that you could fly around in our neighborhood, and it was gone after 7 days. So it was pretty sad. People felt really bad.
Barbara,
But,
can I share?
about the app, I didn't know about the Merlin app for a long time, and I hope most of you probably know about it, but if you don't know, you can ID bird calls and songs. And it's really great. You download it from the iPhone or whatever. And
Thank you, Sandra. And Carol, I think you have a
I just live a few blocks from Jenner, so I have to share my story too. I was outside in the morning and I heard this call, this cry. I went and got my Merlin app, turned it on, and it said red-shouldered hawk. And I said, come, let's find this bird. And sure enough, we had 2 in the neighbor's tree, 2 red-shouldered hawks. That is a first yard bird for me. So keep your eyes open and use that Merlin app. It's amazing.
Thanks, Carol, for sharing that. And I think both those stories are a great lead into our talk tonight by Mark. So for those of you who don't know, Mark is Professor of Biology at Hutchinson Community College, and part of his doctoral work he did on the importance of animal communication, in particular songbirds. So thank you, Mark, for talking to us tonight, and big round of applause for Mark.
Thank you, Barbara. So I don't know how much I'll actually be talking about Merlin, but it is an incredible app. It does work very well. I have used it a few times. But I will mention how Merlin works to some degree, what they base Merlin on. So here's kind of the typical bird songs that you'll hear in the eastern deciduous forest in the United States. Not in this part of Kansas, but in eastern Kansas you could hear some of these birds. And I'm originally from Arkansas, so I wanted to play this as kind of a demonstration of how, when I was a teenager back in the 90s, I learned birds in northwest Arkansas, hearing their sounds and tracking them down. So it took a while. I remember one summer in June, I had never heard does anybody recognize any of those birds there? I had never heard most of them. I was living in a residential backyard growing up, you don't hear these. They may pass through on migration, but you don't know what they are. I hear a wood thrush in there. Maybe a yellow-throated vireo. But I would go out and try to track all these down. That's mostly what I was doing, back in those years when we would go camping. So bird songs provide us a way of finding where birds are so we can identify them. And using Merlin helps quite a bit as well now that we have this technology. And then once you find a bird, you can see what it's doing. The sounds are kind of a window into their lives. So this kind of song you're hearing here, this would be in June or July or maybe in May, early on in the season. But right now is actually kind of a funny time to be talking about bird song because a lot of the birds are quiet. Very quiet during September and October. Sometimes you'll go out into the woods and you'll find it's eerily quiet. And where are all the birds? They're not doing this. Most of these are bird songs, and the way I use these words, a song is a sound made by male or female birds, but it's primarily for mate attraction and courtship. And birds primarily do that during the breeding season. So right now you don't hear as much of that happening. So here's some of the things that we'll talk about tonight. I'll show you a little bit about how scientists visualize sound using spectrograms. So in my story of research on birds, I studied chickadees when I was in graduate school at Purdue University. And I had not really had a huge interest in studying bird sound before I started working with people who were studying chickadees. And so I learned how to look at the sound and how to analyze different aspects of it. I was interested in the chickadees because they were a flocking bird. Sometimes if you find the chickadees, you'll find all the other birds around them. But I found out the chickadees have an amazing communication system. And so I'll talk a little bit about that towards the end of the talk. We'll talk about how the environment where a bird is found, whether it's the forest or in the grasslands, or maybe sometimes sounds that humans produce in urban areas, does that affect the bird song? And how do bird songs differ from calls? So I use the word call to refer to the sounds that any bird makes. They could be squawks, chips, chirps. Whereas the song is a particular sound made by songbirds, male or the female, often for courtship reasons or defending their territory. So we'll discuss how those sounds are different. And if you want to get into it, we'll talk just a little bit, or maybe more than a little bit if I have time, about the issue here we have with chickadees in town. We have two kinds that may be around, and they can be very difficult to identify. So I'll show you a little bit of how you can use sound to, and Merlin can't tell the difference very often. How you can look at them and think about, well, what is this thing that I'm seeing? What kind of bird is this? And some of these things may provide opportunities to bring up more questions than answers. I'll try to provide some hypotheses that are out there in the scientific literature. But there is a lot that's unknown about bird sounds, and it's a place where everyone can make a contribution by recording birds and sharing the sounds that they hear. So first, just a little bit about what bird sounds are for, and communication in general. With communication, you have a sender and a receiver, and sometimes it is going in both directions. But the idea of a vocal signal in particular, so here we have western meadowlark. Let's see if I put the right sound in there. So that's a western meadowlark sound. You can hear them more often in the spring and summer. So other meadowlarks are listening to that. At first they did a song, and this would be a call. And that's another call. Go ahead and get him to stop. Well, he may not want to stop, so I'll just speak as the meadowlark is singing. The idea is that with that sound, it can convey information to the ones who are listening, and therefore it can reduce conflict. So if this meadowlark is singing and there's a neighboring male nearby, the neighboring male could come over and fight with him, or could listen to his song and see, well, I don't want to fight with that male, I know he's there. Birds actually recognize who their neighbors are by their sounds, oftentimes. It's been shown in multiple species that you can say that's this particular individual. They identify their neighbors by their sounds. And they know that's just Bob over there singing. I don't have to worry about it, because I fought with him before and I know what his sound is like. But there's also females listening in on this. So you kind of can't take apart the two things that they're doing. They're singing to advertise their territory, to say this is my territory, stay away. But it could be males or females listening in and just seeing what is the quality of that song. And that's what I had here in this picture. Bird watchers or eavesdroppers. It could be predators, it could be bird watchers listening in, it could be female birds of the same species listening in. So the sounds are not always going just to the intended receiver. And the interesting and neat thing about vocal communication is that birds can send signals across long distances. They don't have to go over and look and see what their neighbor is doing. So how do we look at bird sounds and visualize them? And as far as what I was going to say about Merlin, it wasn't too much, and I'm not an expert on it, but from what I understand, what they actually do is they turn the sounds that birds make into a spectrogram, and I can tell you about how this works, but they've trained the machine learning computer algorithms to recognize the picture of the sound, rather than the sound, the wave itself. Because apparently that's easier, because we already had picture recognizing algorithms that computers can use. And this is what they're training Merlin on. So let me see if anybody recognizes this bird sound. And what you can see on the graph there, this is the time on the x-axis and frequency or pitch on the y-axis. Does anybody recognize that one? Tufted titmouse. So you hear these high-pitched sounds first, and you can see how they rapidly drop off. And that produces kind of a snappy effect. The idea of a spectrogram is you're visualizing the sound. You can see whether it's like a whistle or a high-pitched sound like we had at the beginning, or a sound that spans a broad frequency range and is kind of harsh and buzzy, like those notes at the end. So let's look at a little bit more of what you can, the kind of information you can see from a bird sound. So this is a picture from Cornell's Macaulay Library showing two things, and we're mostly going to be looking at spectrograms of bird sounds, so like here at the bottom, but you also have the amplitude of the bird sound, and some scientists will concentrate more on that. How is the volume of the sound changing with each note? Another general thing to point out about a bird song, for example, is it's a combination of notes. So birds will string notes together to make the song, notes of different kinds, and then there'll be a space, and then it sings again with a different or the same kind of song there. So these would be whistles right here. I'll give you another example where you can actually see and hear the sound at the same time. You can see some of them drop down, and you can see little rapid chirps that form a trill right there. So the idea of the spectrogram is you're visualizing what the bird is saying, and Merlin lets you do that too. I think as you're playing it, it actually shows the spectrogram. It should record them so you can go back and look at it. This might be a good time to mention this so I don't forget at the end. There's a neat field guide if you want this kind of thing. there's an entire book which is called The Peterson Field Guide to Bird Sounds by Nathan Peplow, and it's basically pictures of spectrograms of bird sounds, like that, for all the birds in the eastern North America. So if you were really into that kind of thing, if you recorded a bird and Merlin couldn't figure out what it was, or somebody told you, I don't know what that is, you could look through this and try to visually match it. Of course, that's what Merlin does with a computer. But they have an actual field guide that has all of those species spectrograms in there. So here's an example of a bird song. See if anybody recognizes this one. But I'm mainly putting this out to show how the different elements sound. So you can kind of predict what that might sound like. This is a bird that does not breed in Kansas. This is a white-crowned sparrow, but they are here in the winter. And sometimes in the early spring, you can hear them singing. One thing about white-crowned sparrows is that they only have one kind of song that they sing. And they learn the song. So male white-crowned sparrows learn that song from other males around them. But there will be dialects where other nearby areas separate may sing a slightly different tune. So if a male's on the boundary between two areas, he may learn two songs. But otherwise, they just have one. It's fairly complicated, but that's what they sing for their main song. And this kind of thing, when you hear it, it may be difficult to visualize what's going on. Sparrow songs are so complicated. So that's why the spectrogram is useful. You can see what the notes are in there. And so I would encourage people, if you're using Merlin or some app to record bird sounds, to look at what the spectrogram looks like, to see if you can notice the whistles and the buzzy sounds. Are they dropping or rising in pitch? Here's one that has a strong rattle at the end. Maybe you can predict what this is. A very common marsh or wetland bird in Kansas. Okay, that's a red-winged blackbird, and that rattle at the end is right here. Here's one that's not very common in Kansas, but it produces a neat sound. It has a long trill after a buzz, and it's varying. This is just the first one. This is a blue-winged warbler species that you can see kind of in the Ozarks a little further east. In Kansas, it's a fairly rare bird. But a really interesting buzzy song. You can see that on the spectrogram. So one thing about songs in general to point out is that most species songs are very species specific. This is you can see the picture of it there. White-throated sparrow. The sound kind of is like what you'd predict, fairly even pitch. And so these songs that they sing actually require learning in songbirds. So songbirds are a particular taxonomic group. Not all birds' sounds are learned. Calls are often instinctive. So if that's my species, I'm going to call like it. Whereas songs have to be learned. And sometimes songbirds will be exposed to weird sounds. And I'm not talking about like a mockingbird, which will mimic anything, but a young bird, when it's learning to sing, if it's exposed to other kinds of sounds, it may actually start singing a song which is not its appropriate song. And that's been shown experimentally in a couple different ways. If you isolate a bird, like this is a swamp sparrow, this is what its song at the top is supposed to be. They isolate them in the lab in a cage. It sounds like this. It doesn't learn by hearing anything else, it just makes a basic, some kind of instinctive sound. Maybe it has the trill, but all the notes are incorrect. Here's the song sparrow. And they also have to be able to hear themselves sing. So experimentally, they actually deafened a bird to see would it be able to learn to sing? So birds hear their neighbors and the neighboring males or their parents. That becomes ingrained in their memory, and then they start singing it, and they hear themselves, and they're trying to match it to what they learned from their neighbors. Now I assume that there must be, and this is where I'm a little bit fuzzy on what the current research is, but a reason that they would tend to learn their own species song, because most species in the wild, they will preferentially learn their own song instead of another kind. And I won't go into the full detail on this, but it's pointing out that birds have a certain period of time when they're learning. The beginning is just listening, the sensory period, hearing what's around them, to do the song, and then they actually start doing the song, or it's a sensory motor. In the song, at some point in songbirds, and most of them, becomes crystallized. And some of them can still modify it after that, but a lot of them, like the sparrows, they're kind of stuck with what they've learned during that early point. Now mockingbirds and some of the mimics may not be that way. I'm not sure on what the mockingbirds are doing. We'll just talk a little bit about mimics later on. And calls are completely not like this. This is the white-throated sparrow call. People can learn how to recognize that, and maybe Merlin can. Sometimes I don't know if Merlin recognizes calls very well, but the birds can tell what it is. And if you're well practiced in listening to those, you can recognize that. But it doesn't look very distinctive. It's just like a little chip. It sounds a lot like a cardinal, whereas the songs are very species specific. And that's because the songs are for the male and female to recognize each other as their own species, whereas these sounds have a more wide-ranging function. Sounds that are called calls could be for saying just, here I am, or there's some food over here, or there's a hawk diving at you. I'm going to chip very quickly, make these rapid twittering sounds. So they are multifunctional, and it's possible in some cases they may even serve a cross-species function, where one species can hear another one. And because they're not all that different across species, they may serve a similar function. So as far as bird songs, I do remember when camping as a kid in the Ozarks, we would hear a lot of them early in the morning, even before it was light. And there's several hypotheses for why birds sing early on in the morning, more so than later. It could be because the sound travels better at that time of the day. It's usually calm and still, and the air is cooler. It could also be because it's too dark for them to do anything else, and so it's not a cost. Very small songbirds, not like owls, but small songbirds especially, cannot see as well as we can. In this kind of dark room, if one was sitting there, you might be able to walk right up to it and grab it. Maybe it has to be a little darker. We can see in the light that a bird cannot see, especially the smaller ones. So if it's too dark to do anything else, it may be a good use of the bird's time to sing. It's a good time to listen to them as well. So with birdsong, it's often long been the notion that male birds do most of the singing. And so I wanted to point out right away that very recently, people have always known certain female birds sing, like cardinals, but it's been found that a lot more birds than we expected, the females are singing. Let me show you what the female cardinal sounds like. So there's actually a project where people can record, if you can find a female bird singing, and upload sounds, called the Female Birdsong Project. And on there, oh, that's not showing up. Maybe I can't click to the website. 1 second here. Let me exit. There we go. This is a male northern cardinal sound shown in blue here. And so it's to some degree unknown entirely what the female birds are doing with the sounds, the more well-known ones, we do understand that the females are aggressively singing back and forth to a neighboring female, as well as singing in courtship songs back and forth with their mated male. So that's the female northern cardinal song. And a lot of people do realize that female northern cardinals sing. And on this website, if you go on here to femalebirdsong.org, you can see lots of other examples. Let me play one that's, I think, is kind of an impressive example of a wren called the Rufous and White Wren that is in tropical America, in Central America. So here, the red is the female and the blue is the male sound, and they do a duet. And that's their characteristic sound. So if you hear that, it's two singing at once. And they're advertising not only is the male here, the female's here to the neighboring male and female. This spot is taken and this mate is taken as well. So it's advertising two things. So cardinals also have a call, and I'm just kind of threw out when I play a bird song, I'll also play a call, so you can see that the call is not as distinctive. So if this works, a little video I've embedded here, when it plays, there was a biologist who used to work in southern Indiana, Indiana University in Bloomington, Rod Suthers, who worked on bird song vocalizations. And he made some neat animations of showing what the bird's singing organ or the syrinx is doing as the bird is singing. So like, how are they making these sounds? And it's similar to our voice box, forcing air through a small opening. But the bird's syrinx has two openings that it can force air through. So they can actually make two sounds at once, simultaneously. Or while making one sound, they can switch sides. And that's one of the things the cardinal does. It just plays the sound first, and then it shows you where the syrinx is. So this is just the breathing. So as the bird's breathing out, it can make these sounds. Breathing in. And that's the spectrogram at the top right. He slowed it down. So let's have a little bit on the other side to finish it. Like one side's not enough. And here's a brown-headed cowbird. If you've heard brown-headed cowbirds, the male fluffs up and does a visual display while he makes these high-pitched whistles. So it slows it down again, so you can hear what's happening better. Because it's breathing in and out, getting ready. So that's a slowed down song. If you slow a bird song down, it will reduce the pitch so you can hear it better in some cases. And I have not used this, nor do I know much about it, but there's actually an app and a website by a bird sound recordist, Lang Elliott, who has this device. It's an app called Hear Birds Again that slows bird sounds down for people who have high frequency hearing loss. They sound different, but you can hear them. And it has headphones that go with it. He has a whole system. because he lost his high frequency hearing when he was a kid from a firecracker going off. So Carolina wrens show an interesting thing. I said the white-crowned sparrow has one kind of song, the male learns. Well, Carolina wren males will have up to 50 different songs, or 30 in some cases that they can sing. And you may have to listen for a while to hear them change. So here's one, and it'll play this one at the top left, and then the top right. And I'm going to slow that down so you can see what the pitch is doing as you look at the spectrogram. So that was the top left, and now it switches to the top right one. And what this sounds like to birds, we don't actually know, but it is known that birds have better temporal perception than we do. They can hear things that are faster. So these tiny differences between little tiny sounds, they may be able to hear much better than we can. Here's a couple more of the 20 to 50 that they do. And neighboring males will sing a similar song. They have a similar repertoire. And if they match their neighbor's song, it's generally seen as being more aggressive signal to neighboring birds, especially if you actually overlap the song. But in general, they'll sing the same one. But it gives them some kind of flexibility to change. And of course, the female is listening to this as well. And with Carolina wrens, they're related to the rufous and white wrens that did that weird male-female duet in the tropics of the whistles that I was playing. But the female Carolina wren, although she doesn't sing in the same way as the male, she will give little rattle calls and buzzes while he's singing. So it's kind of a similar duet type thing that she's involved in the sound making, either communicating to him or to other nearby wrens. And female Carolina wrens will face off against the other female in the neighboring territory when there's a contest between two pairs. So here's just some numbers on different species and the number of songs they have. You might think the northern mockingbird with its mimicry would be the top. And sometimes when I hear brown thrashers, I think that they're just doing random stuff. But apparently they actually have a particular number of songs or sounds that they can make, and it can be a lot. And they are a mimic like the northern mockingbird. The other one that's pretty high up here is robins. There's an ovenbird. And what that eventual over on the side means is that those species, where it says eventual, wait for the ovenbird to stop here. They will eventually change to a new one, like the song sparrow will sing one song for a while and then switch. Whereas the American robin and the brown thrasher switch immediately. Like song to song, they sing a different song. And the people who study bird songs will look at these and say, this song has an A note in it or a B note, and they give them letter designations. And they'll map out what is the bird doing with these sounds. Why they're doing it, we sometimes have no idea. But just describing what they're doing is kind of the beginning step of this. And one thing in general to point out is we don't think that these sounds, especially the songs, all mean something that's very complicated. It's basically showing off that I can sing this, like playing a guitar solo. Each note doesn't necessarily have a particular meaning as words do in our language. It sounds incredibly complex, and the male and female birds listen to the elements of it, but it has a different kind of meaning, like how well can they do it? I'll talk about that with chickadees in a little bit here. And here's the robin. I was just mentioning robins. This was kind of interesting to me because I hear robins all the time, but having recorded some and looked at their sounds, what you can see is they actually sing particular song notes, and then they can rearrange them in different orders. I'll play this in low pitch so you can hear the song notes better. So it starts on the top left and then goes to the right and then to the bottom. So it has these distinctive notes and it can reuse them in different orders. If you did that in all possible orders, you could sing 100 to 600 orders of those, but I guess they only sing about 50 to 70. So they might prefer certain ones that they've learned in that particular order. Here's a really complicated song by a fairly common bird in Kansas in the summer. The song at the top is pretty long. That's an indigo bunting. I'll play this one at the bottom first. Indigo buntings often repeat notes, so you see a similar note repeated, 2 notes back to back, and you can actually hear that too. So here's this one at the top. I won't play that one slowed down. I want to kind of move on to the next bird here. But indigo buntings also do have a call, which sounds a lot like a cardinal. Again, calls aren't that specific to species. So I am kind of curious if Merlin can recognize the calls yet. I bet it will be able to, if it can't already. Here's a Baltimore Oriole. Again, just noting the difference between the song and the call. It's the song at the top right there. And then here's the chattering call that they give. It is also known by the way that female and male orioles will sing. And I'm not going to say much about mockingbirds because I don't know much about them, but what are they doing with their sounds is an interesting question. And this is a mockingbird. See if you can guess what part of the United States this was recorded in by any of the sounds that it does. There's only one in here that I recognize, you might pick up on. Does anybody have a guess of where that mockingbird is?
In the desert.
Yeah, somewhere in the Southwest.
Mm-hmm.
And I don't know if my ears were playing tricks on me, but in southwestern Kansas a couple years ago, I heard a mockingbird sound what sounded like a buff-collared nightjar call. Maybe it was a vermilion flycatcher, but it was one of those two. I don't know if they're learning that from having been further southwest or from hearing from other mockingbirds that travel around. But they're an interesting conundrum. What are they getting out of doing all of that? Why are they so plastic compared to other birds? And there are some scientists studying that kind of thing. But I wanted to point out, I wanted to point out another bird that you may not have thought of as being a mimic. The white-eyed vireos are mimics. They don't mimic songs and do it over and over. They mimic calls and they remix them into their own little song that they do. Does anybody recognize any of those sounds in there? Let me show you this here. So this is Cornell's sound analysis program, Raven, and there are others you can do this with as well. So this is one of those white-eyed vireo songs. If I just play this first note, maybe somebody recognizes that one. Downy woodpecker. Both the one from what I had from Texas and North Carolina, they both did a downy woodpecker call first.
Is that the Texas
I think so, yep, because the other one says North Carolina. And then this one, I don't recognize that by looking at it. If you hear it, you might. It's a great crested flycatcher. And some of these I can't quite tell what they are, but the white-eyed vireos are in some way hearing song notes from someone else and remixing them into this little thing that they do. When you hear it, it just sounds like, oh, that's a weird song, but you don't notice all the time what that is. And I do not know how much research has been done on them. So I wanted just to talk a little bit about environmental influences on bird songs. I may not do too much on this, so I can move along with my talk here. It's been a while since I've done this talk, and I didn't know how long it would be. Whoop. Okay. So there is quite a bit of work looking at how human-produced sounds or natural sounds affect birdsong. Over here, you're looking at the sounds that dippers make, and pointing, this frequency graph here is pointing out, now frequencies on the x-axis, but it's pointing out that the dipper sounds are high frequency, and perhaps that's to avoid the noise of the streams that they hang out near. And there has also been work showing that when you play noise, like say traffic noise or urban noise, just kind of white noise, it causes birds to raise their pitch to go above that. I won't click on this link here because it'll take me off of my slide. But if you heard about this during COVID, when not many people were outside doing a lot of things, there was a story going around in the news that bird songs were becoming more complicated because it was less noisy. And so there actually was a study looking at that they were singing softer and particularly quiet elements that they don't normally do, or they had not done in those areas for years, I guess. I assume if you go out into the silent areas, you could still hear that. But in the cities, it was actually changing because it was quieter. And I'll kind of go through these next ones pretty quickly. These are actually frog sounds, not birds. But these are frogs that may be singing apparently in the same area. Notice how they're all singing at a different frequency. So they may have adapted sounds at different frequencies to avoid each other. And when they're all singing at once, so how do you deal with that? Well, they are actually tuned to hear their frequency the best. And it's thought that bird hearing may be somewhat that way, maybe not as strongly so as the frogs. But there is this real effect. It's called, with humans as well, the cocktail party effect. If there's a lot of people talking, it can be difficult to isolate one sound. And that's a problem I have with my hearing. Birds are able to track their species-specific sound, I think, better than humans are. Able to track like their friend's voice from across the room. They actually key in on that particular sound. So another aspect of the influence of the environment on birdsong is that different environments have different acoustic properties. In a forest, you have lots of little things that the sound waves can hit and reverberate off of. Whereas in grassland, it's very windy, but there's not much that sound will bounce off of. So this graphic in the middle is showing that, in general, low-frequency sounds travel farther, but also they're less likely to bounce off of objects because they travel around things like trees and branches better. Whereas high-frequency sounds are much more likely to hit little tree trunks and branches. And so this is a hypothesis. I'm not sure how well it holds up, but scientists have made the hypothesis that birds in forests should sing lower frequency sounds. So you could kind of think about forest birds you've encountered. Do they actually sing lower frequency sounds? Not all of them do. But here's a couple examples of forest birds with relatively low frequency songs. This is a summer tanager. And I need to play its call, of course, to reinforce the point that calls are different from songs. Those songs are actually one that was in Oak Park in Wichita this summer, the song in that call. The picture was not, because I could never see it. There we go. Red-eyed vireo is another kind of low-frequency forest songbird. So then what about grasslands and that type of habitat? With some of these birds we have in the grasslands, you think of their songs as being like what often? They're higher frequency sometimes, but they're also, well, this one's complicated. Let's go to the next one. They're also often buzzy. They have buzzy elements. One hypothesis about this is that wind noise is very difficult to get sound through. And so by repeating an element many, many times, it's more likely that a bit of that sound will get through the wind by having lots of rapid little sounds. So here's a grasshopper sparrow. And it's pretty high frequency and buzzy. I shouldn't ignore this one because this is another common breeding summer bird we have in Kansas, the lark sparrow. Their songs are quite complicated. They have many elements too. Not as buzzy and high pitched though. Let's play this one here at the top right. Here's that same song at the top right, slowed down. And I didn't pull up the spectrogram for this one, but Dixisils also have a buzzy sound. Yeah, fairly high frequency. So there may be something going on there where habitat affects the sounds birds make. And I'll try not to get too detailed into this chickadee part, but I think it's an interesting situation we have with these two chickadees right in this part of Kansas, if you're not aware of it. The Carolina and the black-capped chickadee, definitely black-capped, but probably Carolina are in Sedgwick County. And there's a zone of overlap between them. Black-cap is the northern species, it's a little bit bigger. And I won't go into the visual differences, they're subtle, but you can kind of tell. Carolina's a little bit smaller and grayer, and it's the southern species. And that green line, this map was created by David Sibley. There's apparently evidence of where they're overlapping, where both are found. You see part of it goes right through Wichita, or maybe through the southern part of Wichita. I don't know what it does here, it just sort of peters out, because they both disappear when you get onto the plains. And so an interesting question is, if you hear one, can you tell what it is? And what would you predict based on what we've talked about with songs? Maybe it's possible, because songs are species specific. But we also know birds learn songs from their neighbors. And it's possible for a bird to learn the wrong song. Here's, if you use eBird, this is showing eBird observations of the two species. You can again see we're kind of right on the boundary there. Just southern and southeastern Kansas has the Carolina, though mostly it's black-capped in Kansas. So they've been researched extensively in Pennsylvania. At Villanova, Robert Curry has worked on these birds for quite a few years. And they've determined that the hybrid zone between them, where they're actually hybridizing, they're breeding, is moving northward at a rate of 0.7 of a mile a year. Apparently because the Carolina chickadee is moving northward, and females seem to be leading the charge in some way, but also apparently female black-capped chickadees prefer to mate with male Carolinas, given the chance, which may be propagating it north as well. So they could be replacing them. In Wichita in 20 years, are they going to be mostly Carolina chickadees? Is it moving that fast here? It's interesting to know how they figured that out, if it's moving that fast in Pennsylvania. So here's a map of Carolina chickadee sightings from eBird in south central Kansas, and you can see some recent ones there. I've never seen one in Sedgwick County or heard one, but there could be some here. Because when you hear them, it can be confusing about what they are. So let's listen to a few chickadees to see what their sounds are like. This is a black-capped chickadee. It's often described as saying, "Hey, sweetie," or I like cheeseburger as well. And that's the song. The chickadees, where their name comes from, is from this call, which is their chickadee call, because it kind of sounds like chickadee, and the last note is low pitch, like D. So here is his normal speed chickadee call. And this is slowed down, partly just for fun. You can hear what the chickadees might be hearing. It takes a while to get them out. So what does Carolina chickadee sound like? My research on chickadees was on their call, not their song. But I heard them singing all the time, so sometimes I would record it to see what they were doing. And this is a Carolina chickadee song from northwest Indiana, where weirdly there's Carolina chickadees, because the hybrid zone goes up north as you go further east, even though that's much further north than here. So it's often described as sounding like Phoebe, Phoebe. It usually has 4 notes, but they can also do a 3-note song. So, what kind of song do we think that one is? So I looked into this a little bit by looking up some sounds. I'm going to get out of my slideshow here real quick and show you this. On the Macaulay Library, these are Carolina chickadee songs. You can find this in eBird pretty easily. If you go to Explore Species, you can find all these sounds that have been made by that species and people have recorded. This is Carolina from Kansas. Here's another Carolina chickadee from Kansas doing a 3-note song. Or, no, this is not Kansas, this one's Maryland.
That one has catalog number, 1
So what about black-capped chickadee songs? Well, they also do a 3-note song. And the other twist to this is Mark Robbins at University of Kansas, who curates their sounds there, and he's recorded a lot of bird sounds and also does genetic work on birds, recorded this chickadee sound in an area that has almost all birds being hybrids. You can tell me what this one sounds like. It sounds like a black-capped chickadee, but it may very well be a hybrid. He didn't have the genetics on that bird, but a lot of them there were hybrids. So with black-capped chickadees, there's a lot of variation in the sounds they make. So here's a 3-note black-capped chickadee song from New Jersey. And I won't play all of these, but it gets weird in the Pacific Northwest. Now, this one's just Nebraska, I guess it's not that far away. And most of them don't do that, but you will hear the odd chickadee doing things like that. I guess up in Oregon and Washington, they do this sometimes. That's Alaska, actually, further northwest. That sounds very strange. So they have kind of dialects, apparently, and can learn from each other. So in Kingman County and out near Cheney Reservoir, I hear a 3-note song a lot from black-capped chickadees. And I don't know what they're doing. If they're learning it from Carolina, if it's just a normal 3-note song with the black-capped, or if they're actually hybrids with Carolina. So this is just to point out that it's difficult to figure out. If you know what they look like, you can usually tell what the bird looks like it is, at least. This one's a little faint, but I recorded this chickadee song down in Mulvane. That's really hard to hear, but you can see on the spectrogram, it's going Phoebe, Phoebe. We're just doing that over and over. So I think that may be a Carolina doing a 3-note song, but I'm not sure. Or it could be a hybrid, likely. And the last twist to the chickadee story is just researching this recently, apparently female black-capped chickadees sing occasionally. And that's a female chickadee song on the spectrogram. Usually if you hear them, they do the standard song that you expect. But if you hear something strange, it can be interesting to try to think about what are they actually doing. And sometimes looking at it on the spectrogram helps. Now you wouldn't know it was a male or female unless you were doing research on them and watching them very closely. Or maybe even doing genetic tests, because they don't look different. So let's talk a little bit about the chickadee call. This is the call of the chickadees that I actually did work on and studied. Well, first of all, you might wonder, can we use this to distinguish the two species, black-capped and Carolina? So this is a Carolina chickadee call. And here's a black-capped. Do you hear the difference? The black-capped notes at the end are lower, maybe, and they're slower. More like D, 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 whereas the Carolina chickadee is faster. However, I think that the calls may be difficult to distinguish as well as the songs. So these are some chickadees I heard in Wichita. Sounds like almost kind of like a Carolina. It's pretty high pitched. I don't know. There's some other ones that I heard in Wichita. And they look like black-capped visually. They have all the marks of the black-cap. This one at the bottom, which is a bad recording, I heard these up in Hutchinson, where I work there at the Dillon Nature Center. So I'll go walking over there occasionally. And this was in August, so maybe they're young birds, but these are definitely black-capped chickadees. Let me wait for those ones at the top to finish. There we go. So this is the bottom right spectrogram. They're making a very fast sound. Maybe hard to hear. It's extremely rapid, and you can see on there. Little tiny notes, very fast. What are they doing? So I think the thing to consider with chickadee calls is they vary a lot with what the birds are doing. What I realized after watching chickadees for a number of months and years is that they almost tell you what they're doing. You don't always know what it is, but if there's a bunch of them hanging out together, they're making different sounds. Then if there's just one or two calmly feeding, they make different sounds. If they're flying, they make different sounds. If there's a predator there, they make different sounds. So all of that affects what they're doing, makes it really interesting. But it does make the call a little bit different or difficult to distinguish between Carolina and black-capped, because black-capped can speed up in some situations. So this thing about bird calls, just to transition into talking about bird calls here a little bit at the end. I think bird calls are just as interesting as songs. Most songbirds have a call. A lot of times they look simple, but birds can do things with them. Here's a chickadee with a seed in its bill. This is a Carolina chickadee. But in the winter, they may stop singing a lot of times. Although Carolina chickadees start singing pretty early in the season. But what can you tell from their calls? Well, calls can tell all kinds of things. Flocks of birds coordinate their movement with calls. They may signal distress. It may also have something to do with courtship and finding a mate. By looking at that call, you can guess it's a pretty noisy one. Maybe make a prediction about what that's going to be. It's a quite noisy bird. And crows don't sing, they are a songbird. Blue jays don't sing per se, they are a songbird, but we generally call the sounds they make calls, or caws in this case. And as far as blue jays, not much is known about them and their call. I'm going to talk a little bit about the chickadee call here. What do calls mean? Like, are birds actually using these sounds to refer to things? maybe not this complicated, but, or are they just kind of squawking? Like, see, picture like behavior of an animal, like a dog. It gets upset at someone walking down the street and makes loud barks. It hears you come home and it whines. These sound like emotional sounds to some degree. We may not want to put human emotions onto animals, but it's impossible to deny that they have a psychology and hormones that are doing similar things to our brains, perhaps. So are birds doing that? Or is it more like words? They're calculated. And they're actually like saying, here's what I want to tell you. So some research with alarm calls in particular has shown that birds are referring to an event or a particular type of predator with the type of call that they give. So chickadees do this, tufted titmice do it, a lot of birds will. They have a different call for an aerial predator, a very dangerous bird flying by about to eat you, compared to a big owl or a hawk just sitting there, compared to a cat. The work has been done with jays and crows in that kind of regard as well, and even chickens. And one thing about it, it shows that it's not just like emotional utterances, is that they do it in some situations and not others. It's been shown with small chickadee-like birds that they will give an alarm call if their family members or mate is nearby, and they're less likely to do it if they're alone. So they don't just sort of like, they're not just like emoting these crazy sounds, oh, there's a predator coming at me, and squealing, but they're actually doing it for some particular reason, it seems like. We don't always know exactly what's going on, but these sounds do seem to be referential. And that's been shown with some mammal calls as well. Certain primates have that kind of thing that they do. Monkeys. So just to point out, Carolina wrens again have really interesting calls, and I am not an expert on wrens, so I won't play all of these perhaps, but they make a lot of sounds. Those are wren calls. So are they saying something with this? Why do they do one or the other? It's not a song. Males and females do them both. Carolina wrens are permanent residents in their area. They're there year-round. So it may be because they have a very stable social system. They've developed more complicated interactions with their neighbors. This is just a guess, and so they need a complicated communication system, rather than just being neighbors who are together for a day or a week. They're always around their neighbors. General thing about calls, I don't have the sounds on these, but you've noticed throughout, the calls are these broad frequency sounds across from low to high, and they sound very snappy. It's thought that sounds like that, and clapping, for example, are easier to localize. And so these calls may often be saying, like, here I am. And it's easy to see that you're here. It's easy to hear that they're there as well. And they don't have to actually see the bird to tell, because they can hear it. Birds can do things with these, even though they're simple. They can increase how fast they do them. So if a predator flies by a cardinal, a hawk comes at a cardinal, it'll rapidly chitter with those notes very quickly. Or if it's fighting, it'll do them faster. The chickadees are interesting because their chickadee call is not a song, but it's not just a single note. It's very complex. So here's a Carolina chickadee call. And it's thought to be involved in everything chickadees do. So amongst species related to chickadees in the family Paridae, there's tufted titmice and other titmice and chickadees, and there's European species. And all of them more or less have kind of a chickadee call, where they do certain notes in a particular order. And the interesting thing about chickadees, well, why do they have such a complicated call? Their social system, at least the Carolina and blackcaps, is in the summer, they're like a normal bird. They hang out, male and female, have a nest. In the winter, they get together with their unrelated neighbors and make a flock. And they do that year after year if they're in the same place. So the same unrelated 3 birds, or 5 or 6 or 8 birds, will be hanging out in a flock every winter. And so perhaps they need a more complicated communication system. This is a hypothesis that biologists have about it, to negotiate that continually stable social situation, but also shifting dominance hierarchies. There'll be like a dominant male and a dominant female, and they can like take food from the other one and steal things. Of course, the titmouse is dominant over all of them because it's bigger. Here's the titmouse chickadee call. Notice how it's a little bit simpler. They call it a chickadee call because it's the same general idea. High-pitched notes always come first and low-pitched notes second. Well, titmouse doesn't have the same social system. The tufted titmice, at least, their flocks are family groups. They're not unrelated pairs that have to get together and wrangle who's dominant every year. So they may have a simpler communication system without as many notes and sounds because it's their family and they've been together for a while. So the chickadee call, its notes are described in orders. The first high-pitched ones are A's, and you go down the line, it's B's, C's, and D's. And they always give them in that order, but they can leave out any note. And they can change the number of any note. So they could do just A notes and then one C. I don't know if they do that very often, but they could do just A's and then a bunch of D's. Or they could do only D's and leave off the A's entirely. So the chickadee call is an interesting communication system because they can convey high-pitched sounds, and high-pitched sounds are generally harder to hear for one thing, and maybe harder for predators to hear too. They don't propagate as far, they bounce off of things, they have a kind of ventriloquial quality, you can't tell where they're coming from sometimes. And this is a chickadee's alarm call if it sees something really dangerous like a merlin or a sharp-shinned hawk. Here's the tufted titmouse alarm call. That's actually kind of hard for me to hear if it's not loud enough. And the robin has a very similar alarm call, at least high-pitched. So in the chickadee call, it has high-pitched elements and low-pitched elements. The low-pitched elements seem to be more related to aggression, and the high-pitched elements seem to be more related to things they are afraid of. Now, I don't know that it's an emotional thing, but they may be able to communicate lots of fear by putting more of the high-pitched notes, or dangerous situation at least, and lots of aggression by doing more of the low-pitched notes. In fact, there have been experiments, and you may have heard of these, with chickadees, black-capped, showing that if there's a more dangerous predator around, they give more D notes, which are the low-pitched notes, more aggression. And it's a little bit confusing because what they're really afraid of is a flying predator, because that's the one that might be coming at them. So that's the most dangerous situation. And if they see like a merlin or a sharp-shinned hawk or a Cooper's hawk even, although they're a small meal for Coopers, they will give these high-pitched alarm calls. And that kind of situation is usually when it's flying by. If it's just hanging out in a tree, sitting there for a while, maybe it's not hunting them, then they may get angry about it and start giving the low-pitched sounds. And they always do those low-pitched sounds, something like a screech owl. But these birds don't like screech owls because they are sometimes predators of small birds. But screech owls are not nearly as immediately deadly as a merlin or a sharp-shinned, which will dart after you and grab you like that. A screech owl, if you get too close to it, they might come after you in the evening or the early morning, but they will mob them intensely. And when they're mobbing, they don't give these high-pitched sounds, they do this kind of thing. This is a chickadee mobbing call. Titmouse mobbing call. And a nuthatch mobbing call. There are two nuthatches there. So the interesting thing about these birds, and I know this is a lot of stuff here, but the chickadees and the titmice hang out together in the winter woods. You can see this in Kansas here. The research has shown, there's not much research into it because it's difficult to find out. It's one of the things I was trying to figure out, but it's shown that the chickadees seem to follow the titmouse more than the other way around. Titmice are about twice as big and they're dominant, but the chickadee may gain from the anti-predator signals of the dominant titmouse. And then this, at the bottom, you may have witnessed this. Nuthatches almost always follow the other two. They almost never lead. They're generally thought as satellite species. They kind of, downy woodpeckers, red-bellied woodpeckers do the same. They'll follow the chickadees and titmice through the woods. And there, while they're looking down at the wood, or the nuthatch is literally upside down looking at the tree, it can listen to the sounds the other birds are making, whether it's these kind of sounds for birds coming right in at them, really, really dangerous, or maybe there's a screech owl nearby that you want to watch out for. So that's presumably why these birds that are not very vigilant, like woodpeckers and nuthatches, follow them around. And one of the things that I found interesting, though, is that nuthatches do mob screech owls very intensely. And that's the sound of a nuthatch mobbing one of my screech owl models that I use doing my research. I would play the screech owl call and get them to come in. And the nuthatches were often the first ones there. So maybe the nuthatches, after all, are doing something useful to the ones that they try to just sort of follow around all the time. This might be a little bit intense, but this is what it sounds like when they all three mob something. And the weird thing about these three species is you'll sometimes hear them doing this, and you can't figure out what they're doing. There's not an owl nearby, or you don't see it at least. So I don't always know. And presumably the function of that kind of thing is to disturb the predator enough that it withdraws or leaves. I've seen nuthatches mobbing an owl and they didn't get it to leave. As soon as blue jays flew in, though, the owl was like, it popped its head back into the hole. So I think screech owls may be afraid of blue jays, but not these guys. Or maybe they're just annoying. I'm not sure. Because usually the screech owl doesn't leave when they do that. So maybe they're just conveying information that here's a screech owl. And they tend to do when the owl calls, because then you know, maybe that's how you know the owl is there. You go check it out, yell at it for a while. It's like a neighborhood thing they do. You have to find it every evening. Where is it the next morning? Where is it gone? So an interesting question about that is, are they actually communicating across species? Like, do we think, and I don't know the answer to this, I didn't really discover this, and maybe people are still working on it, is the chickadee actually saying something to the titmouse, intending to send a signal? Or are they just doing it at the same time and listening in? So like, if you're doing it, I'm gonna do it. Here's an interesting example of this. Get to listen to a Carolina chickadee for a little while, singing. That's kind of quiet. I'll just describe what happens. It may be too quiet to hear. This is a Carolina chickadee singing, and I was recording it. I had no owl or no model, or I wasn't playing any sounds at them. And the Carolina chickadee singing, and then somewhere right around here, the tufted titmouse starts calling. And immediately after, the Carolina chickadee switches calls to its harsh call. So what is it, just listening, like, oh, the titmouse is loud, I'm gonna be loud too. It's a good chance to be loud. Or is it actually saying something to the titmouse? This is kind of an unknown, what they're doing. But they both have very similar sounds, and they're related birds. Let's see if we get to the loud sounds here. And that's kind of quiet to hear. I won't linger on this, but they're both being pretty loud at the same time. And so I always kind of wondered, are birds really communicating across species? Just a question that I was never really able to fully address. I studied what they were doing as they were mobbing. And so we're kind of getting to the end here with some of these interesting questions that I'm posing. The calls are very unknown as far as how they're used and what are they all saying. And I found this study just a couple months ago. This is where our technology has gone today. It's pretty incredible. A scientist based at the University of Windsor in Canada, Dan Mennel, and his student Zach Gack looked at migrating birds, not perched birds. So they've done this in the tropics too with birds in forests. They set up a microphone array, triangulating microphones, so that when a bird calls, they know where it is. And so they set this array up to listen to nighttime migrants. A lot of these songbirds migrate at night. And what they found is that birds that are migrating through the array at the same time by their sounds tend to have similar sounding calls. And it's suggesting that birds that are similar and make similar sounds, like tiny warblers or little vireos, or maybe a thrush and another thrush, actually are migrating together in mixed species groups, which would suggest that those similar sounds actually help them communicate and stay in touch. But sometimes when you see a group of birds in the forest, you wonder, how did they get together? Just as randomly. But sometimes maybe during migration, they actually arrive together as a group, intentionally communicating with these little sounds at night that sound like beep, 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 beep. They don't sound like much, but to the birds, they're kind of similar across species. This is a whole area of sound that's gotten crazy in the 15 years since I was doing research. People record bird migration sounds at night, and they can identify those little bleeps and bloops and chips that they do. And they do it with computers, or they do it by ear. You just put a microphone up at night, like tonight. You might hear something. Or if you sit out there for long enough, it can be hard in the city. But it's an interesting side of the whole acoustic area of calls. These just little tiny chips that they make tell us that these birds are migrating over at night, when it seems like it's just a black sky. And then I already talked a little bit about blue jays, but I've been hearing a lot of blue jays in the early mornings recently calling. What are they doing? I don't know. They are migrating more at this time of the year. The ones here, I'm not sure if they go south, but others from north will come through. So their social system is in flux, so they may be calling and rearranging what they're doing a little bit. And that's all that I have. I did some birdsong quizzes earlier, so I'm not going to go through these and ask you what all of these sounds are. If anybody's curious, I will. And I just wanted to mention that the sounds that I played, you go back here, were not all my recordings. The chickadees were. My slides are messing up, but some of these came from the website Xenocanto, which is a website where you can download bird songs and listen to them. It's not, here it is. Some of them were from the Stokes Field Guide to Bird Songs. This is an old CD that I learned bird songs from way back. And I wanted just to remind you about that Hear Birds Again website that Lang Elliott has, where you can potentially get this app to lower bird sound frequency to hear high pitches again. The sound analysis software that I made those spectrograms with was Raven, which is like way over the top in what it can do. But there are simpler sound analysis programs, and there are some free ones that you can look at. There's a little app that I use on my cell phone called Song Sleuth, which is terrible at identifying birds, which is what it was for. But it has a little function where it's constantly recording. If you hear a bird, so you're waiting for the bird to sing, you hit the button and then it'll like back up and it will have already recorded that part. So you can catch it after it sings. And I like just recording songs with my phone. I don't carry my microphone with me very much these days. It's kind of a hobby that I dabble in. I don't have a lot of time for research, but if I find students who would like to do research, I will try to encourage them to help me with that. So with that, I'll go ahead and stop and see if anybody has any questions. Yeah?
Is there any research to indicate why some birds, whether it's individuals or species, seem to vocalize almost continuous? I've got a brown thrasher in my yard that is from sun to sun. He's busy he's singing all the time. And I also have an indigo monkey that does the same thing. And it's nonstop. Early on it's entertaining, but it gets annoying. Why do they do that?
Well, at that time of year, it is often the male trying to attract the female, and I don't know why some species would sing. We could probably come up with a hypothesis, but more frequently than others. Now, an individual might sing more than another individual if it's not mated. Oftentimes, a bird that's not mated will sing longer into the summer and just keep singing. than one that has found a mate. At some point they stop or slow down during the actual nesting process. But that's a good, red-eyed vireo is another one that they just sing constantly throughout the day. Brown thrasher, northern mockingbird. I don't know why some would do that more than others, so. Yeah?
What you were talking about with the forested birds versus prairie birds and different call frequencies and everything, I was just gonna make a note about, you were like, there are hypotheses that they might have lower pitch in the forest, but
Yeah.
I know that there are studies on that with bats, and the echolocation frequency and everything for bats, and the different niche specific patterns and, like, pitch of the different bat species depending on where they're trying to navigate. And above the forest or in the forest catching insects, if they're like, you know, short range sort of picking up on prey sources. And they also have little bursts when they get close to prey that has a range of different pitches to help them
Neat.
pinpoint on exactly where that insect is.
So bats are changing it too. We can't hear those mostly. They do have there are devices you can buy to hear or detect bats that bat researchers use.
Yeah. Well, I guess my point was more like, I'm sure
Right.
it is, you know, it might be a hypothesis, but it would make a lot of sense that that would be a
Yeah.
thing, considering it's been studied with bats for sure.
And I think people have looked at it in birds, but there's always exceptions to these things when you
Yeah.
look at like how many of these birds are doing it. And then I think about the Blackburnian warbler. Well, it's at the treetops, so maybe it can do high pitch. Yeah.
Birds spend a lot of time singing to each other during the day. What are your thoughts on the impact of playback?
I think during the breeding season, and this is partly what I've learned from what others have said, that it can be dangerous to use playback to the bird because you're taking it away from what it's doing if you do it over and over and over kind of thing. But I've also heard the other side of it, and I kind of see this as well, that if you want to see a bird and you play a song one time to it and it pops up, you've seen it and you can leave it alone. And you don't have to mess with it and hang out all day thrashing around where its nest might be. So I can see it that way too, but I think overuse of playback does potentially distract the male bird in particular. And he is, during nesting, he is helping with the feeding, usually not as much as the female. But he is taking him away from his nest attending functions if they're breeding. He's referring to the idea of people sometimes playing bird sounds to get the birds to come out so you can see them, and then do it again, and then do it again, and go back there and do it again every time because you know it'll get them to come out, that kind of thing. So some people do that and some don't like doing it because you're disturbing it. There's differing opinions about what effect it has on the birds.
You have the same opinion about fishing then?
I have heard the similar opinion about fishing, but so in taking the conservative view, when you're fishing to a bird, it makes it pop up, it's coming out of the safety zone. But I do fish to find birds. But if they don't pop up, I just leave. So fishing, if you're not aware, is making this kind of sound, and I'm not great at doing it, like psh, 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 psh. Like it's like a Carolina wren or some mobbing call, which will make a bird attracted to you so you can see it. So I don't have a strong opinion about fishing. But I think during the breeding season, again, it could be most dangerous to them. And you know, there could be a predator around. I mean, I have been watching birds sometimes, and you're like fishing, figuring out, is there a bird here? And then you see there's a sharp-shinned hawk sitting right there. So I think it's worth considering how we're affecting the birds with what we're doing. But especially during the breeding season, because they're focused on one particular thing, they may be distracted from predators nearby if you're doing playback. Yeah?
You mentioned briefly that blue jays are songbirds, but their songs aren't considered songs.
So it's kind of a weird point, I know. So in terms of talking about what a song is, you think of like a male, or the female in some cases, like day after day, sometimes hour after hour, like the brown thrasher singing from a particular place, just belting it out. Blue jays don't do that. They have sounds that they make to each other, but they don't just sit in a tree and do it hour after hour. And they have a huge variety of sounds, some of which I'm unaware of. The other thing that they can do is they can change their calls. And so they make this kind of high-pitched sound, sometimes called a bell call, or it sounds like a squeaky iron gate. And they usually do kind of a visual display where they're like dipping up and down when they do it. And that may have courtship relevance. Maybe it's similar to a song, but they don't use it like a song. You can't just go out every day and hear a blue jay doing that. So they seem to use these sounds for interesting purposes, but we don't know that they're being used the same way other songbirds do. But they're taxonomically thought to be related to the other songbirds. Oh, another thing I might point out in relation to that, we're talking about songbirds learn their songs. Flycatchers, which are closely related to all these birds, do not learn their songs. They're genetic. So eastern wood pewee or eastern phoebe, those are genetic sounds. So if you hear a weird pewee, that may be a clue that it's a hybrid. Whereas with chickadees, it's harder to tell. The flycatchers apparently do not learn the sounds for the most part. They're more instinctive. Any other questions? All right, thank you everybody. I hope to see some people out here again next month. We'll have talks on through the year. And I won't be talking every time, just introducing the speakers.
Well, thank you very much, Mark. That was very informative. Thank you. So just a few other things. I think I saw Liz here a moment ago. There you are. So I just wanted to introduce Liz Walker, our new naturalist at the Chaplin Nature Centre. So last Sunday we had an open house down at the Chaplin Nature Centre. Very successful. Liz had quite a group of children there. I think they were all anxious to pat the tail of the snake. But they were certainly, very thrilled to be out in nature and listening to Liz. So congratulations. And this Saturday, Liz is also running her Fall Nature Day down at the Chaplin Nature Centre. So I would encourage you, if you are not doing other things, to go down there. Certainly many of the birds you were talking about tonight, Mark, are down there, easily seen from the bird feeders at the Chaplin Nature Centre. But I am told by Sandra that both species of the chickadees are down there as well. So if you want to go and listen to some of these birds and see them, next Saturday would be a great time to do that. I was also advised that Bob Walter, you wanted to make an announcement. There you are, Bob.
I'm getting ready to really retire. And I have my library is overflowing. And what to do with all those books that I have. I was born in India. I did my PhD research on a big lizard in India in the Himalayas. I taught 21 years in Taipei American School in Taiwan. I've been to many countries in Southeast Asia, and most places I got books of those places. They aren't restricted to bird books, but I have papers here that where I live in Mulvane, northern Mulvane, and my address and phone number. If you want to come and see some of these books, I'm ready to give them away. And I have lots of books. And so that's my solution.
Okay.
Some of them I'll keep, but I'm ready to part with lots of them. Yeah.
Okay, thank you very much, Bob. So Bob has the sheets there if you want to get his address and go there. And similarly, Bob Gress, catch up with him after this if you're interested in that extended, field trip, in January of 2025, if you're interested in that. Other than that, I would like to thank Laura for doing the refreshments this evening. And I hope you all have a few moments to stop by, chat with the other folks who came along tonight. Say hello to Liz, and thank you all for coming. The next program is Tuesday, October the 17th. It will be the importance of birding to wildlife conservation. So that should be really interesting. Destiny will be doing that. She's a biologist with the
Pheasants group.
with the pheasants, yes. So should be another great topic. So thank you all for coming and see you next time.